The second part of working with rational exponents is actually having you work with fraction exponents that have a numerator other than 1. So I'll be introducing that to you in this lesson, and we'll begin working with that now. Back in the first lesson from 7.2, you worked with problems like this: 64 to the 1/3 power, and that equaled the cubed root of 64 as we worked through all that. So, but the question I have for you is this: where does this 1 end up? Because when you have a fraction exponent like 2/3, we're going to have to deal with the 2 in the numerator. Well, looking over here to the right, that 1 is still over here. Where is it? It's still as the exponent on 64. We just don't have to write it as 64 to the first power. We just write it as 64 because 64 to the first power is 64. So the 1, the numerator, ends up staying with our base number. So then this is actually the cubed root of 64 to the first power. So we're going to look now at things where it says a to the m of n. And now what we're going to have then is we're going to have numbers up here for m, that the numerator, that will not equal 1 and they won't equal 0. We're going to have different numbers up there. So let me show you an example. Here's one: 9 to the 3/2 power. So how do we deal with this one? You know from your past work in lesson 7.2 that this is actually asking, because it's 2 in the denominator, I'm actually asking for a square root here. So I'll make my square root symbol. You know also that you would have taken this 9 and put it underneath here. Now, based upon what I was showing you up here, from 64 to the 1/3 being the cubed root of 64 to the first power, this is the square root of 9 to the third power. So now, what do I do at this point? Well, I will actually cube 9. So I actually then want to say I have the square root of, and 9 cubed, I do happen to know off the top of my head, is 729. Because that's 20 or 81 times 9, and that gives me 729. So I want to look for the square root of 729. I don't know that, so I will need a calculator to do that. So I'm going to take and I'm going to do the square root of 729 right now. So the square root of 729 happens to be 27. So sometimes when we do this, we will actually get an actual number. And I do. I get an answer here of 27. So the 9 to the 3/2 power is like the square root of 9 cubed. I did 9 cubed for 729. Then I did that square root, and I get an answer of 27. Now, let's take a look at this same problem, and let's see if we get the answer. But I'm going to show you a different way to do it. There actually happens to be 2 ways that you can deal with problems like this. 9 to the 3/2 power. That can also be written as 9 to the 1/2 times 3. Because I can now use my exponent rules and say 3/2 is the same as 1/2 times 3. So this is a power raised to a power. So 9 to the 3/2 can also be written this way, that it is the square root of 9, I'll put parentheses around it, cubed. So I have the square root of 9 cubed. So how do I keep working with that? I know the square root of 9 is 3, and I want to then take 3 and cube it, and 3 times 3 is 9, times 3 again is 27. So there are 2 methods to work with a fractional exponent. You will have to decide which one you like better. Will I write this as like the square root of 9 cubed, and then do the inside to see if I can get it that way? Or will I then break apart the exponents and say this is like the square root of 9, and that answer is cubed, and then I cube it to find the answer here. So a few more examples for you. Here is one: negative 27 to the 2/3 power. Negative 27 to the 2/3 power. So taking a look here, I'm going to change my color, erase my mistake here. All right, so we're going to go to red. Red it is. First thing you need to take a note of, the negative sign is where? It is inside the parentheses. That's a key thing as you look at negative numbers and exponents. If a negative number is inside the parentheses, that is not outside of it, so this negative is included with the 27. Now I have the 2 methods that I showed you up above. One method would be the first one. I'm going to take this and I will write the cubed root of negative 27 squared. The cubed root of negative 27 squared. Well, I don't know negative 27 off the top of my head, so I'm going to have squared off the top of my head. So I'm going to do that on my calculator. 27 negative, and my squared function is right here, so I'll tap that. And it says this is also 729. So then I have equals the cubed root of 729. And I need to find out, is there a cubed root of 729? I don't know that off the top of my head either. So I'll have to bring my calculator back. And I want the cubed root. Some of your calculators may have a cubed root function like this one right here that I've got lit up in yellow. This is a cubed root. You want to look for a function like that. If it doesn't have a cubed root function, you want to look for the one now that I have highlighted yellow. And it shows you this function here where it asks for which specific root do you want. So on this calculator, I'm going to actually use the cube root function. I have 729. I'll type that in first, and then I want to press my cube root button. And it tells me right here the cube root of 729 is 9. Let's try it with the other button. How does that work? What I do is I type 729. I will hit this button, and now I have to tell it which root I'm after. So since I'm after the cubed root, I'll tap a 3, and then I hit equals, and it gives me that cubed root answer. Notice I got 9 either way. So to do that, and I'll say my answer here is 9. To show you the other method, if you choose to break this apart, okay, I would say that this will now equal negative 27 to the, and I have 1/3 times 2. So that is then the same as the cubed root of 27, and all of that squared. The cubed root of 27, I happen to know that. The cubed root of 27 is 3. So now I'm going to do 3 squared, and that equals 9. So I can do it either way. Just pick the method that works best for you. I will try to do some of each as we go through here, but you pick the one that works best for you. Another example, we have an expression to the 2/5 power. All right, we look at that and say, wow, I don't know what x is. What am I going to do? Well, let's just use the top method to start with up here. We're going to figure out what root we're going to do, and then we'll put our expression underneath, and then we'll see what happens. So to do this, I have a 5 as a denominator, so that means I want a 5th root. So I'm going to 5th root, and I'm going to put this out here. I will write my expression 2x plus 1 underneath. So what is this then? What do I have to do with the 2 that's up here in the numerator? That means I am after the 5th root of 2x plus 1 squared. Now, how many times underneath the sign am I multiplying 2x plus 1? Just twice. Will there be a 5th root that I can do algebraically for something I'm only multiplying twice? No. So at this point, I leave this in its radical form being with a radical sign. So I have the 5th root of 2x plus 1 squared, and I'm finished with this problem now. A couple more. Not too many left. Negative 256 to the negative 3/4 power. I have a negative exponent. So when I have a negative exponent, the first thing is this. I have to write that as, I have to use that reciprocal, so I'm going to show some division here. It's going to be 1 over negative 256. And now I have the exponent of positive 3/4. So then I have a positive exponent. I've done that reciprocal. I've put it down in the denominator of the fraction. And now I have to deal with this part right here. Keep in mind this negative sign now is outside. It has no parentheses on it. So that means it is negative 1 times 256. So as I deal with this under my radical, I'm going to be writing a fraction the whole time. I'm going to have 1 over something. Well, I am 1 over, I have a negative times the 4th root of 256 cubed. And the cubed is inside the radical sign. So what happens now? 1 over, and now I got to do 256 cubed, which I obviously won't know off the top of my head. So I'm going to clear my calculator and do 256. And my power button is right here, x to the y. On a lot of your calculators, it's going to be that little pointed arrow key. But on this one, it's x to the y. So I tap that key. I tell it I want it to cube it, so I have to have a 3. And then I hit equals. That is a large number. Very large number. I need to get my calculator out of the way. So now I need a negative 4th root. And I got to bring this all the way up here. I need my calculator back because I don't have that number memorized. So it's 167. And then 77 to 16. 7, 7 to 16. So that number underneath there would have to be 16,770,216, and I want the 4th root of that. I'm sure we all know that off the top of my head. Since this number is already in the calculator, I'm going to use my root key, and I'll tap that key, and it says, now what root do you want? I want the 4th root, and I would say on almost all your calculators, you're going to need this key. So you want to look for that. And then I said I wanted the 4th root, and what do I get? I get 64. So I did all that work to get an answer that equals 1 over negative 64. So the answer to this is then a negative 1/64. Lots of steps there. I know this video is starting to get long. I got one last example for you. What do I do when it's y to the negative and I have this exponent? Well, it's not as complicated as the last one. It's simply this, 1 over, and I'm putting y as the denominator, and I put 2/5. And now, is there anything else that I can do with this? No, I'll just leave it like this. The other option possibly that you might see in an answer key from time to time would be this, 1 over the 5th root of y squared. Now, mathematicians, we don't tend to like roots in denominators, and you're going to learn about what we call rationalizing denominators later in this chapter. So do not write one like this. We tend not to like, we don't like radicals in our denominators. So because of that possibility, this one is only left as 1 over y to the 2/5 power. All right, what I'd like for you to do to practice that, I got it right down here. Page 427, please do numbers 17 through 40. Turn that in when you get it done. Please make sure that you check your answers. You're probably going to want my answer book because I am assigning a lot of even numbers on this one, so be sure to use my textbook to check answers. Good luck. Please let me know what I can help you with.